is, right?
Just imagine a giant amoeba.
It reminds me of
New York.
that movie. You ever seen that movie World War Z? That was the one zombie movie. Like, generally speaking, growing up in my life, I was scared of zombie movies, but that one scared me the most because it was actually feasible, right? And like it was a virus making everyone turning into a zombie instead of like, who knows what. God
What about
punishing
I
us.
Am Legends?
I Am Legend. Yeah, yeah.
That takes place in 2021.
Those were.
Vaccine.
I didn't see those guys as zombies, though, right? I saw them as like, I don't know. I don't know what I saw them as, but for some reason my brain didn't think of zombie whenever I saw those guys. It was more of like vampires almost, right? They only come out at night and they run like crazy and they're kind of smart and they don't say brains all the time and stuff like that. This is good to put on the recording. I'll have to hack this off at the beginning. Okay, let's get started. Open up SQL Server Management Studio and get into AdventureWorks. Oh man, I'm telling you, I love to live in SQL land. This is the, I don't know. I don't know if this is my favorite part of this course or if the part where we actually get to integrate SQL into the projects into the development environment, if that's my favorite. But anyway, this part is the most important, right? So learning the basics of SQL, and we've already started doing that. Went over a little bit of it before we ended class last time. Make sure when you start your new query that up here at the top left-hand side, AdventureWorks 2012 is the selected database, and then we can get started. So we have, we've already talked about some syntax. We've talked about select and from, and we've used the where clause a little bit. So I think I'm actually going to start off with a question to you guys. So what if I wanted to create a query that selected every person in the database from the state of, oh goodness, this is going to be a weird one because I don't know what states are in there. Let me do a, where is it? Data mining operation here. Oh, I hate them. Oh, they try to normalize this stuff so much. So their state province ID is literally an ID. Why wouldn't they just put the state inside there? Because there's other information, Matt, that's why. Okay. Address type. We'd have to find out where that stuff actually is in order to do it. Okay, so I mean this will work the same way. Let's say I wanted all of the people who are from state number 58, whatever that means. We can't yet use our knowledge to figure out what state 58 is, but we can select all the people. So let's say I just want address address ID, city and state, where state is 58. What would that look like? Go, tell me.
You would select the address ID and the city and everything else that you wanted from the person.address table.
Yep, that's right. Person.address. Well, let's do this so we don't have to qualify these all the time. I'm gonna put my from in first. Address. That way, when I'm at, so if I don't put the from clause in first, then IntelliSense doesn't know what table I'm pulling information from, and so when I list the attributes, I have to list them fully qualified. So person.address.something. Whereas if I list in the from what table I'm pulling the attributes from, the fields from, then I can just do address. No. Address ID, city, and state province ID. From person.address, and then what's going to be in my where clause?
state province ID equals
State province ID, use the equal sign. So yeah, this is not Java or C# or C or anything like that. Equivalency operator is just a single equal sign. So equals what? What do I type there? What do I need to check to see if what do I need to check to make sure I'm typing the right thing?
if it's an integer.
Right, yeah, so you got to go check the data type of whatever it is that I'm comparing it to. And I can see right here, state province ID, first off, it's a foreign key, which means that, and we'll talk about this later, but I talked about it in general. In a different table, state province ID exists as the primary key of that table. That's what a foreign key means. Purposes of foreign keys are to keep data consistency between relations, between tables. So it's to make sure that any state province ID I put inside of here also exists inside of that other table that has state province ID as its primary key. So state province ID is an integer, so I need to put an integer value over here. So 58, I don't need quotations around it, single quotes in the case of SQL. And then I should be able to execute this thing. Where's F5? There it is. And then I should look at state province ID column, and we get some results from that. How many are there? 1105. So just over 1,100 are from state ID 51. I have no idea what state ID 51 is, but obviously there's a lot of them. Now, what is it? Oregon? What table are you looking at?
I'm just thinking yes.
Oh, you're just shot in the darking. I thought you were actually looking it up. Yes, so 58 is obviously Oregon. Why wouldn't it be, right? Oregon is so 58-ish. That's why it would be that. Okay, so, oh no, it makes more sense, right? Portland, Oregon City's in there. Come on, you got to tell me you're using some context clues before I make an ass of myself. All right, so probably Oregon, right? We can assume, but we can know 100% what it is if we go find the table where these IDs reside and we look up 58 and all that stuff exists. Sometimes the tables, especially in this database, are a little bit cryptic, but the process, in fact, let's just go through it, right? Let's go try to find the table that has state province ID inside of it as its primary key, and use that to figure out, I mean, obviously this is Oregon, but let's use it to make sure that it's Oregon. So this process we're going to go through, I mean, it seems like a mundane process, but this is the exact process that you have to go through whenever you're developing against a database that you're not 100% familiar with the schema of. You have to use your knowledge of the inner workings of whatever database management system it is that you're using, and your general knowledge of SQL and things like foreign keys and things like that, in order to figure out where the data that you want resides. And I mean, a lot of times, there are times, like when you're developing and you're at a larger company and there are dedicated database managers where you don't, I mean, sometimes you don't even write queries. You just say, hey, DBA, I need a query that does this. And they write it for you and they give it to you. And then you just incorporate it in your code. And that's kind of nice because then you can blame the DBA whenever something goes wrong, right? So that part's nice. But most of the time you have to go through this process that we're going through right now. You have to figure out where stuff is using context clues and everything else. So what do you think? Where should we go? Person.state province. That one was pretty obvious. So here we go. For the big thing here is state province ID is the primary key here. So you know that this is the table from which this foreign key inside of person.address exists. So we can go out here and we can just select stuff. Select everything. Well, select everything from person dot state province. And you can just go look at it, right? There it is. So we've got state province ID. The one we're after is 58. So we go through and find 58, and what do you know? Lo and behold, it is Oregon. Now in a little while we're going to figure out how we can write this first query that we wrote here and replace state province ID with state province code from this other table. Draw in this other table and put that data inside of here rather than displaying some weird state province ID. So if you were writing some sort of interface for this, you'd obviously want this, right? You would want this state province code, or no, that's okay. Yeah, I was seeing what that country region code was. I wonder what all these things stand for. We'd have to look it up. Oh, there we go. Ontario, Oregon. Gotcha. All right. So this code right here, country region code, you can see from the schema of this table that that is a primary key somewhere else. And so country region table is right here. You probably exist inside of there. And so if you wanted to display the country or region, the actual name instead of the code inside of the address. So if you wanted an address, city, state, abbreviation, OR in this case, and the country region code, you would actually have to put together 3 tables, right? You'd have to put together the data from 3 different tables in order to make that happen. The person.address, person.state province, and person.country region are the 3 tables you would have to put together in order to just to get that little piece of information. That's a lot of work. But in a properly normalized database, that's the kind of stuff that you have to do. And so you have to get really comfortable with joining tables together, which you will. In fact, we may have our first SQL quiz just for the fun of it on Wednesday, like the last 20 minutes of class or something like that. A real simple one, just where you're selecting from a single table and doing some wheres and stuff like that. Nothing where you're joining anything or anything like that. So let's plan for that too. We'll have our first SQL quiz, and then we'll take the test on Friday, and that'll be the entire time. Okay, so test Friday, quiz today. All right, so good job. We've got what I wanted. Everything from 58 is inside of there. The next thing that we need to talk about, we talked a little bit about logic operators. We used and we used or. There's also another logic operator called not, right? So you guys are used to this being an exclamation mark, but in SQL, it's the word not, N-O-T. So that one exists also. And I'm not gonna spend a ton of time on those logic operators because they work the exact same way that they've worked in everything else that you guys have used. And so if we run into a situation where I need to use one and it functions a little bit differently, then I'll explain it. Otherwise, just assume it works exactly the same as the logic operators that you've used in the past. Except if you guys use bitwise logic operators in assembler or something like that, that's just completely different. So anyway, yeah, that's good. So we wrote a query. So let's say we didn't like the names of some of these attributes. So like when we executed this thing, address ID, city, and state province ID, we didn't want it to appear that way. And most of the time this happens out of efficient coding, right? So it would be convenient if the database would yield names, attribute names, field names, that we could directly use inside of our interface, right? You probably don't want to plaster address ID without a space inside of it to a user. So you would have to take that and you'd have to, make your own label or whatever you want to do, and then, hard code address ID inside of there in order to display something that is user friendly. Well, we have the ability in SQL to alias any of the objects that are inside of there. So objects include fields, attributes, or tables as well. So you can alias table names, but it doesn't, aliasing a table name doesn't help you, well, help, quote unquote. It doesn't make sense to use it unless you're joining multiple tables. So, because you never really reference the tables later on. I mean, you could if you wanted to, but unless, if you've got a single table inside of there, there's no point in aliasing them. So, if I wanted address ID to be something different, say I wanted it ADDR space ID, something like that, then I would use a keyword as, and this is, yeah, this is gonna, I'm gonna try to force it. Hold on a second. Okay, yeah, so if you're gonna put a space inside of an alias, be sure and quote it, because if you don't, it will see that space as the beginning of another statement. And so just be sure and put single quotes around whatever it is that you're aliasing. As long as you're using underscores or something like that, then it's going to be cool with it. And well, I want to show you something else. I'm going to alias this as something else. I'll alias state province ID as state, so I can show you something. Oh no, I'm thinking, sorry, I'm thinking table aliases instead of attribute aliases. So yes, this is good, right? So now we have address ID set and we've got state set. So now whenever we display this, whenever we get the results from it, field name, address ID is changed to ADDR space ID. City's the same, and then we replace state province ID with state. You guys okay with that? So you can alias any of the fields that you want to, or you can not alias any of the fields that you want to. And again, the reason that you do this is readability, and that's really it, right? So if there's cryptic stuff and you kind of want to translate it, you just use that. Again, it's different whenever you're talking about aliasing tables, but when we get to that point, I'll show you guys. Right. So next thing the book talks about is using, oh, Jennifer, what's up?
What was the commenting to comment out?
Dash. Yeah. Or in SQL Server, you can use /* for block commenting, and then */ to end it. But line commenting is --. Yep. Next thing the book talks about is selecting calculated attributes. So let's say, oh goodness, what would be a good one for this one? I'm going to go into pay history really quick. So let me select everything from human resources dot employee pay history. Take a look at that really quick. Okay, yeah. No, that's not a good idea. Okay, yeah, this will be fine. This will be a good example. So calculated fields inside of a select clause. So let's say we want to do business entity ID, and I want to do that particular person's pay rate multiplied by, I don't know, 10%, something like that, right? I want to see what a 10% raise would do to the bottom line of our company or something like that. So I'm gonna select maybe business entity ID, and I'll alias it as ID. And then I'm going to select the calculated field. Now the calculated field comes from existing fields. It doesn't necessarily have to. In fact, you can just put whatever you want to inside of here, right? So like if I just wanted, I don't know, for some reason to display the number 2 in every single row, I could do that, right? You can do 2 as, I don't know, some number for whatever reason. Now, you can use arithmetic operators inside of SQL, and they work just like normal arithmetic. So it's just like inside of Java or C#, the asterisk is multiply, the slash is divide, plus, minus. Concatenation also works. Concatenation works differently inside of here, so I won't say that. So let's do, it would be rate times 10%, 1.1 as new rate. And then execute that. Oh, sorry, executed both queries. There we go. Right, so this is the result of everyone's new pay rate after I give them a 10% raise. And then this is just illustrating, I can put whatever the heck I want to inside of an alias and it'll work, right? I could do some sort of equation inside of there as well. I can put anything that I want to. I can add attributes that don't exist because again, this isn't a true projection, right, in the formal sense of the word, because by definition a projection requires that the resulting relation be a subset of the attributes inside of the original relation. And obviously these don't exist inside of the original relation, so it's not a true projection. So, but, I mean, that's the difference between theory and reality. Anyway.
When would you do that? Like, when would you use it?
When would I use? You use it all the time. So, gosh, I'm trying to think of a specific instance when you would do this. Oh, I mean, okay, so we're going to get to it eventually, but there's a lot of times when you want to calculate like summations of things and stuff like that. So you want to sum a group of objects. You would use sum, but that's a grouping type. That's an aggregate function. I mean, I don't know. I can't think off the top of my head exactly why you would want to use some sort of calculation inside of an attribute. I mean, maybe I don't know. Maybe the addition of 2 different attributes inside of a single table means something. So, like, there's some numeric field plus some other numeric field yields some value that means something to you. That would be a case where you would want to use arithmetic to calculate that. And again, like this new rate right here, I can easily calculate that without using any of this, right? So if I just did a straight select, if I just did select from human resources dot employee pay history, and this is a difference in theory between 2 different ways of thinking about this. So if I'm a developer and I'm pulling data from the database, the first thing I ask myself is, how much of the data that I'm pulling from the database do I want to massage inside of code, right? How much of the data inside of the database do I want to do calculations on after I've already pulled it from the database? Or do I want to do those changes to the data in SQL, and so that way when I get it in my code, all I have to do is just display it or whatever. Usually the answer is you want SQL to do it just because it's more efficient at doing the work, right? So like in order to do the calculation that we just had to do, you'd have to set up some sort of loop, and you'd have to loop through all of the values, and you'd have to store them inside of an array or something like that, and you'd have to multiply them by 10% and store that data and then do something. SQL seems like it's doing that process, but since it's doing set operations, it's actually not going through all that trouble. It's doing stuff way more efficiently than you can inside of code, especially when you're talking about iterations. The way that SQL Server actually assembles that data is way more efficient than anything you could ever do in even assembler. It wouldn't make a difference, right? The SQL just does it better. That's what it's designed for. So usually the answer is, I want to do all my calculated values in SQL, pull them into my code, and then just use the values from that. Specifics about what you want to calculate and what you want to do, it could be a billion things. It could be a billion things. Any other questions about that? No? All right. So arithmetic operators you can use inside of select, and I don't know if it'll be this next quiz, but I'll definitely give you guys one where you'll have to do it on a SQL quiz, just to show you guys an application for it. Angel, what's up?
If you take away the as due rate, will it just return rate, but still be 1 point?
Ha ha ha, watch this. So the question is, if I get rid of the alias, what does it return? It returns no column name. So almost equivalent to null, right, in terms of the attribute name. It just doesn't have one. And so in code, rather than being able to access that attribute through a name, you would have to do it through an index. So you'd have to do it through index 2 as opposed to being able to access it through its name.
But it still returns the same data.
Yeah, same data. You just didn't alias it, and so it doesn't know what you want to name it, so it just says whatever column. And this varies, obviously, from application to application. Like if you did the same thing in like Access or something like that, it gives you a different value for the column name. I think they do. I think Access does like COL1 and COL2. It abbreviates it that way. It's just, whatever the system is that you're using will have its own default for if you don't alias something. So any calculated value that you use inside of here, and again, this doesn't have to be, again, let me see if there's another, okay, here we go. Pay frequency, right? So let's say instead of doing rate times 1.1, I did rate times pay frequency, right? You can do that. So now I took their rate and multiplied it by, whatever their pay frequency is. And so that would tell me depending on how the business model works for the company, maybe that tells me how much they earn per month, right? Whatever that means. I don't know if pay frequency means 2 times a month, 2 times a week, 2 times a quarter. I don't know. But somewhere in the database it knows. So it doesn't have to be an attribute and then some arithmetic with, some constant value. It can be, arithmetic between attributes. You can chain it as much as you want. You can make that arithmetic statement, as big as you want to, right? As big or as small as you want it to be. And so I'm not going to go through examples of all of those because I think that you guys get the gist with just this, and I don't want to spend a ton of time on that unless you guys have questions. So, if you got questions, ask them, and I'll harp on stuff if need be. Oh, let's see what they got next. Okay. Oh, okay, yeah. Inequalities. So you can use inequalities in the where clause. So let's say, let's just stick with business entity ID, pay history. So let's say I want to get all of the people in employee pay history whose, what is it called, whose pay rate or just rate is between, I don't know, I'm assuming this is an hourly rate. Let's say it's between $20 and $40, right? We got to set up an inequality to handle that. I want it between, non-inclusive, between $20 and $40. So I've got select everything from human resources employee, where what? What am I going to put in the where clause? Yep, I want the rate to be between $20 and $40, or 20 and 40, whatever 20 and 40 means. Maybe it's rupees. I don't know.
Rate is greater than 20.
Okay, where rate is greater than 20
And less than 40.
and rate is less than 40. Is that right? Is that the right logic? So the comparison operators inside of SQL pretty much mimic the ones you guys are used to. So greater than, less than, greater than, equal to, less than, equal to. All of those things mimic what you guys are used to. So that's pretty much the same. So does this logic work though? Does this give me the things that I want? You guys are just going to launch it and find out. So let me just do the same thing. All right, so let's just take some. Are there any in here that are greater than or equal to 40? There's one that's really close. All right, 39.6635. That's pretty stinking close. But we don't have any that are 20. We don't have any that are 40. And none of them exceed 40, and none of them are less than 20. So there you go. Good stuff. Now, if we wanted it inclusive, we can do that. I don't know if that changes it. I don't know if anybody has exactly 40. I wish that this, hold on a sec. Okay. So 69 rows. And look, this is the way that you test this stuff out, right? So if I'm looking at 100,000 rows, I don't want to just I don't want to sift through all of them every time I know, right? So I get in 69 rows whether I'm doing equal to or just greater than or equal to. So obviously nobody has a value that's equal to 20. And again, that's another thing that you can check, right? If I wanted to check if anyone's rate was 20, really quick, select star from human resources employee pay history where rate is equal to 20. If I can spell where. All right, I don't get a result, so there's nothing there. That's a lot faster than going through the entire thing and just slowly going through. Oh, 25 is one, right? So 25, so I can say where rate is equal to 25, right? Got a bunch that are at 25. 23 of them have a pay rate of 25. Now, on top of learning the SQL, right, you also need to learn SQL Server Management Studio, right, and the way that it works. So, like, you can easily shift between including this where clause and then just including everything inside of the table just by selecting and executing after you've selected, right? So, like, if you're not sure, like, you're getting 69 results from this, but you want to compare that to all of them that were in there. There's 316 that are inside of there. And then you can just do a real quick calculation on a calculator and figure out if the number of rows that I'm getting back from that is what I expect, if we have an expected number of what's going on. And a lot of times, little stuff like that will tell you whether or not there's some sort of bug inside of your code. So being able not only to not only to write these queries, but to also be able to manipulate the interface, this development environment that we have, so that you get the things that you want out of it are super important. And again, so I've got 4 queries inside of here, and if I just F5, I can launch all 4 of them at the same time and just kind of look through them and figure out exactly what's going on. But select and execute is one of the most useful things. Like, there's times when I've got SQL files that are at least hundreds of lines of code that are inside of there. I've got, I don't know, 50, 60, 70 queries inside of something when I'm doing something that's complex, trying to pull everything together. Some of them are huge, some of them are small. It's really convenient to be able to stay inside of that one interface and then use those different queries and selectively execute pieces of them to get information out of it, especially when we start joining tables. When you start putting those joins together and you're not getting the results that you want, being able to piece that stuff together and selectively executing portions of it is really important. And I mean, quick commenting, sometimes you got to do that also in order to make that stuff work. All right, so are you guys okay with inequalities, with comparison operators? Obviously, the equal signs there as well. Last time we talked about comparisons with strings, right? So I don't think I have a string inside of here. So we need, human resources dot employee has what inside of it? Business entity. I want to get to actual names. User data, that's not going to help us. Human resources department. Help me find names. It's got to be like business entity. Here we go. Person.business entity. Business entity, Roy. Of course. Hate you.
What about person not person?
Where is it? Person? Person type, name style, first name, middle name, last name. Yes. Here we go. Now we got some text data that I can mess with. So we're going to select everything from person.person. See what we get inside of there. Oh, yeah, all kinds of good stuff, right? So there's old Ken Sanchez? Oh, yeah. Yay, accent mark. Terry Duffy. We've got all kinds of people inside of here that we can mess with. Man, they had to come up with all these names. I wonder if they just used like, nah, they probably wouldn't have done that. I bet they've got like a name generator or something at Microsoft where they just... Yeah, that is, 19,000. But you got to think, this includes employees, but it might also include names of people for vendors and things like that. So all kinds of stuff can be inside of here in a normalized database. But we can do this. Let's select some good information, kind of whittle this stuff down. First name, last name, and there's no other useful information. I guess business ID is useful. Business entity ID, first name, last name. All right, here we go. So Kim Abercrombie here is listed 3 times. One thing I want you guys to notice, I get 19,972 rows. I'm going to select all 19,972 rows, but I want you to see Ken Sanchez is first, right? Business entity ID 1. But when I execute it like this, business entity ID 285 is first, right? it has randomly decided it wants to list it in terms of last name, right? So again, this brings home the concept of a set, right? The order of the data really doesn't matter. There are default behaviors that every database management system will project onto you, whether you want to or not. SQL Server, obviously, use last name and alphabetized it that way because it wanted to. Mostly because it doesn't matter, right? It really just doesn't matter the order of it because, as we're about to talk about, you're in control of how the data comes out. And this is another thing that you can use whenever you're developing against databases to make your life easier, right? You can choose what order the data comes into you from the database, so that way you can expect certain values to be at the top or at the bottom, however you want it to. And we're going to learn a new clause called order by. This is a multi-word clause. Order must be followed by, right? And then you list the attribute that you want to order it by. So let's say I want to really order it by business entity ID, and execute that. What's that?
I don't want to rush you, but it is 150.
Is it?
But we gave it.
Nicole has failed in her job then. It's okay. It's okay this time. Next time. Okay, we're done. See you guys next time. Remember, quiz Wednesday, exam on Friday. Exam's going to cover all the stuff on the PowerPoint and obviously in your homework. So study up and I'll try to put the PowerPoint out as soon as I get downstairs.